Dear ladies and gentlemen, welcome to the presentation of Mr. Professor Sandkuhl and me. My name is Wuertz, and it is my pleasure to present you the results of our paper. The topic of our joint work is called Towards a Reference Architecture for Demand-Oriented Public Transport Services. First, I will briefly give you an overview. Now we come to the overview. First, we will start with an introduction, including theoretical background, followed by the presentation of a public transport reference model called Ittc core model, in German ETV model. Afterwards, we will have a look at the conducted expert interview in terms of who was interviewed and how the interview was structured. After that, we will look at a general idea that compares pipeline and platform companies and what this has to do with the current topic. As one of the main points of the paper, the results of each section will be presented in a consolidated way. The summary and the future work will conclude the presentation. In the introduction, we will first take a closer look at the object of observation, the Bergkönig, and its operator, the Berliner Verkehrsbetriebe, in short BVG. Let us start with the BVG. The BVG is a public company and is comparable in size to the public transport companies from Hamburg, Stuttgart and Munich combined. The Bergkönig is a collective call taxi with fee choice of destination in the eastern inner city area of Berlin. Bergkönig A is operating in cooperation by the company BVG and Viavan, a subsidiary of the Daimler Group. Viavan operates the service on behalf of BVG and supports management decision by providing information. The theoretical background explained which relevant areas come into play in our paper. Public transport companies, especially the BVG, new mobility service, like the Bergkönig, platform versus pipeline concept as a general idea, reference architecture for public transport companies, enterprise architecture manual TOGA for the documentation, literature analysis and expert interviews as an input, and problem definition. By the way, of further introduction, let us take first a look at intersection of several research areas, where you can find 4 bullet points with the first bullet point, reference architecture for the integration of new modules as part of public transport is investigated. The enterprise architecture management is a basis for transparent documentation. The third point is the determination of the deep of integration of the Bergkönig. And the fourth bullet point is the conceptual creation of an architecture based on TOGA. Next point, we find the methodology. We are here in the second part of the design science research method, where we identify and define the goals for the integration of demand response services in public transport companies. Finally, we find here the central research questions are: what could an integration of the Bergkönig service into a pipeline company look like, based on a sub-area selected as an example? Now we come to the Ittc core model, which is one of the foundations for the creation of the interview and on which the architecture is based. The Ittc core model was developed and maintained by Gero Scholz, an employer of eFood Traffic Technologies AG, as a kind of simplified industry model of traditional public transport. The latest version in 2016 of that model may be found in the publication IT System and Public Transport, in which the domain model describes generic business processes on the one hand and fundamental data structure and classes of public transport on the other. In the Ittc core model, the 42 IT system applications are described in short profiles. Users and actors, roles, are classified in the Ittc core model in 60 roles, which are described in detail the activity profiles. An example is in our paper. The expert interview was conducted with Michael Bartnik on the 24th of March 2021. Mr. Bartnik is a project manager at the BVG in the area of JLB Digital Transformation Innovation. In this context, he was very involved in the Bergkönig project, and the interview was structured in the general entry questions. There was open questions to identify the respondent as an expert. In the main part of the interview, we ask a question about new mobility services, and particularly about Bergkönig, where we, especially the integration of the Bergkönig into the BVG company structure. And in the final part, we ask more about digital transformation and future of the public transport and the BVG. Let me tell you about our general idea, platform and pipeline companies, and what it has to do with our topic. During our work, we notice that there is a correlation between platform-oriented business models that are demand-oriented, like new mobile public transport companies, digital disruption business models and process such as Uber, and pipeline-oriented business model that provide supply-oriented public transport services, like traditional public transport companies such as line operators and like the BVG or HVV in Hamburg. Now let's move on to the results. First, we will briefly explain the interview result using the graphs shown here. In the main part of the interview, we asked Mr. Bartnik whether Bergkönig is supported by an external company. You can see this in the blue box. It is a company Viavan. After that, we ask about the support intensity as well as the IT and technology integration depth. We notice that the support intensity is very high, but the technology and IT integration is almost non-existent. The second result is the architecture work. We started the work to create the function blocks to identify where we need to start. These function blocks are very helpful in structuring and orientating in a complex environment. Now we come to the central result of the paper, the new architecture for the area sales and fair. The central characteristic of this architecture is that at every level, whether technical or business, services encapsulate the provision of functionality and data. With this architecture, complex requirements can be realized quickly via services. For example, new as yet unknown forms of public transport that go hand in hand with new billing systems. This modern architecture accesses standard public transport software at the lowest level, such as PT Nova, based on SAP from Hansecom. In a future architecture, one could rather fall back on microservices architecture. The last result was the architecture assessment, which we did internally. In this context, we will only briefly interpret the results that have not fully met. These are the following three. First, the platform independency. We give them partly met because the coverage of the most important applications and functions by services is not really sure. On the second part is flexibility. We also partly met because the flexibility is provided by orchestrating appropriate services. And the third is simplicity, also partly met because the simplification is limited in the studied architecture. And also we don't or not evaluated the reliability. Now we come to the summary. The observation from the analysis is that the integration of sales and fair management of an NMS into the architecture of pipeline companies to solve the build task, and both approaches were pointed out for better understanding, and it was confirmed in the following section that both approaches can lead to different enterprise architecture requirements. The balcony service is operated to an extremely high degree by WireWAN. The technical and organizational support rendered by WireWAN to the BG is very high. The IT system used are only rudimentarily integrated into the IT architecture of the BVG. This finding confirms the above mentioned objects set by the authors. So the authors have presented the requirement from function blocks and developed a target architecture for the integration of sales area and fair management based on those function blocks in the ETVU industry model. So that was the summary, and now we come to the future works. The integration of further outcoming is to develop key requirements for the platform-oriented business model in the supply or pipeline-oriented public transport companies such as BVG. So that was the conclusion of this work, to go further there, to see what could we do in both parts in the pipeline and in the platform orientation. The second part is a design and develop for artifact that takes into account the further results from one, and the third is a demonstration and evaluation of the artifact of two. Thank you very much for your attention.